So this is our first lesson online, and I just wanted to send out the answers to number 2, 4, and 5 on page 20. So the answer 2 is x equaling 3, on number 4 is x equaling negative 19, and on number 5 it was x equaling a half. So if you did those problems, check your work. So now we're going to go on to page 24, and we're going to go over the one problem at the top that I asked you to try on your own. So we're going to go over the answers, and then we'll go over the graph. So the y-intercept, to find the y-intercept, we let x be 0. So again, let x be 0. When we do so, we would have gotten 3 over 4. So the y-intercept would have been 0, 3/4. The x-intercept is when we let y be 0, which is taking the numerator and setting it equal to 0. So if we take the numerator and set it equal to 0, you should have gotten 3/2, 0. And 3/2 is actually 1.5, so 1.5, 0 would probably be the better thing to write. For the vertical asymptotes, we take our denominator and we set it equal to 0. So we would take x squared minus 4, set it equal to 0. So your vertical asymptotes would have been x equaling plus or minus 2. Your horizontal asymptote would have been when you take looking at the degrees, the degree on top is 1 and the degree on bottom is 2. So therefore your horizontal asymptote is y equaling 0. Whenever we know our vertical asymptotes, we also know our domain. So it's a set of all x's such that x cannot equal plus or minus 2. So if we start graphing these things, we have 0 and 3/4 as our y-intercept. We have 1.5, we have a vertical asymptote at x equaling negative 2. And we have a vertical asymptote at x equaling positive 2. And we have a horizontal asymptote at y equaling 0. So if you draw y equaling 0, you're going to notice something. Our horizontal asymptote actually crosses our x-intercept. And like I said in class, that's okay because of the fact that horizontal asymptotes and x-intercepts are okay. So your x-intercept is allowed to cross it, but you will never cross vertical asymptotes. So then we plug this into our calculator so we can get extra points. For the graph, we have a left side, we have a middle side, and we have a right side. So if you plug this into your calculator, look at -3, -4, -5. In between, since we already have those 2 points, we probably want to see what happens at -1. And then to the right of 2, we would look at 3, 4, and 5. So we go to our table, and at -3, we would have ended up at -1.8. At -4, we're at -0.9167. And at -5, you should be at -0.619. At -1, we're at 1.6 and it repeats, so I'll put a bar. At 3, we were at 0.6. At 4, we were at 0.416, again with a bar. And number 5, we were at 0.3 with a bar. So if we look at our calculator and graph this, at -3, we're at -1.8. At -4, we're at -0.9. And at -5, we're at -0.6. So this side would have done that. In the middle, at -1, we were at 1.6 repeating. So it's going to be up there. So we see that we come down, cross through the horizontal asymptote, and continue. Again, we're allowed to do that because you can cross horizontals, but you cannot cross verticals. And then at 3, we're at 0.6. At 4, we're at 0.4. And 5, we're at 0.3. So those are already really close to our asymptotes. So again, be very close to your asymptotes, but do not touch it. So that would be the answer to h of x. I also asked you to bring back a couple on page 26, which was your k of x and your f of x. Intercepts, find any asymptotes, and plot any additional points as needed. So you could have found all the same information. The one thing I want to make sure you know how to do for sure is to be asymptote. And why do we have a slant asymptote? Because the numerator degree is 1 more than the denominator degree. So I'm just going to write all the parts that you probably should have found. To find the y-intercept, you let x be 0, so you should have gotten 0, -5/3. you should have found the x-intercept. To find the x-intercept, we let y be 0, and if we factor and do the numerator, you should have gotten 1, 0, and 5, 0. On 3, you should have found your vertical asymptotes, and your vertical asymptote would have been x equaling 3. And we probably want to look at our horizontal asymptotes, and there is none. And that's because the degree on top is bigger than the degree on bottom, so there is no horizontal asymptote. And so we were going to see if there's a slant asymptote. And there is a slant asymptote because of the fact that the degree on top is 1 more than the degree on bottom. So how do we find the slant asymptote? We do long division. So x minus 3 on the outside, and we have x squared minus 6x plus 5. Our first multiplier is x. X times x is x squared. X times negative 3 is negative 3x. We change our signs after we subtract, so subtract and change your signs. We get a negative 3x, bring down the plus 5, and start the process all over again. So our next multiplier would be negative 3. Negative 3 times x is negative 3x. Negative times a negative is a positive 9. Again, we change our signs before we draw our line, and we subtract, and so that we end up with a remainder of negative 4. But again, we said disregard the remainder. So all we have to do to find our slant is say y equals minus 3. So this is in the form of y equals mx plus b. So let's go ahead and plot the things that we have. We have 0, negative 5/3. 0, negative 5/3 is in between negative 1 and negative 2. So we'll just put a dot there. We have x-intercepts of 1, 0, and 5, 0. So there's that. We have a vertical asymptote at x equaling 3. So dotted line down at x equaling 3. And we have a slant asymptote at y equaling x minus 3. So we're going to begin at negative 3. And then we're going to go up 1, over 1, up 1, over 1, and so forth. So we have a slanted asymptote of y equaling x minus 3. So then we look at our table, and we find points that are to the left of the asymptote and points that are to the right of the asymptote. Since we already have 2 points over here, I say let's see what happens at 2. And if we look at our calculator, it would be 3. To the right of 3, we have 4 and 6. And again, looking at our calculator to get these values, we would have at 4, we're at negative 3. And at 6, we're at 1.6. So you can see that the graph would look like this, following my asymptotes. Same thing here, follow your asymptotes. And at 2, we were at 3. So there we go. So hopefully you're understanding how to find all this information, looking at the graph, making sure we have the right tables, and plotting our points. The last one I'm going to give you the answer to is f of x. So let's go through the whole list again of the things that I'd probably want you to find, which is the y-intercept. We do so by letting x be 0. The second thing you'd want to find is the x-intercept. To find the x-intercept, we let y be 0, which is letting the numerator equal to 0. And when we factor, we should have gotten 3, 0, and 1, 0 as our x-intercepts. For vertical asymptotes, we look at our denominator, setting it equal to 0. So our vertical asymptote would have been x equaling 2. If we look at our horizontal asymptote, we do not have one because the degree on top was bigger than the degree on bottom. But because the degree on top is 1 more than the degree on bottom, we do have a slant asymptote. So how do we find the slant asymptote? We take the x plus 2, long division, into x squared minus 4x plus 3. The first multiplier would be x, so x times x is x squared plus 2x. We subtract, change our signs, we end up with a minus 6x. Bring down the plus 3, our next multiplier would be negative 6. So we get negative 6x minus 12. Change your signs, because you're subtracting, and we get a remainder of we don't care. And the reason why is our slant our remainder would go to 0, so just don't worry about that remainder. So plotting what we have, 0, 3 halves would be like 1.5, so 1.5 up there. We have an x-intercept of 3, 0, and 1, 0. We have a vertical asymptote at x equaling negative 2. So we're going to have a vertical asymptote at x equaling negative 2. And we do not have a horizontal asymptote, but we do have a slant. And our slant asymptote is y equaling x minus 6. So we'll start at negative 6, up 1 over 1, up 1 over 1, and so forth. So we have a slant asymptote like that. So what do we do next? We make a table on the left side of the asymptote and a table on the right side of the asymptote. Well, you actually can kind of see what's already happening here. We're not going to get close to that asymptote down there, but maybe something else to look at is what happens at -1, and we might want to see what happens at 2. So at -1, we're going to look at our table. We'll see that we go to 8. At 2, we're actually going to be at -0.25. So at -1, we're all the way up to 8, and at 2, we're at -0.25. So it looks like it's going to come down, just barely go through there. We also might want to see what happens, say, at 5. At 5, we're at 1.14. So at 5, we're at 1.14. So it's going to come over towards our asymptote, but not for a while. Now what's happening down here? Well, to the left, 4. So at -3, we're at -24. Well, that's really off our graph. At -4, we're at -17.5. At -5, we're at -16. At -6, we're at -15.75. So it's going to be down here. You still have to draw this piece later on. I'm in the way of it, but it is going to be down there. So I gave you one to show you that if you graph it on your calculator, you might only see this piece, but you know you need something to the left of the asymptote. So even if your graph doesn't show it, it is something that still needs to be plotted. And so I would give you definitely a bigger coordinate plane. So hopefully that makes sense. Let me know if you have any questions. Thanks.